second means hang on, hang on. Yes, and I had quite a few questions on this, and there was an error. Let's see. Oh, I should have written. Oh, I did write the number. Okay, it was number 4 on the 3.04 quiz. And I apologize. Can you guys hear all that banging? Or is that coming through? No? Okay, good. There's a lot of banging that I hear because they're putting the gutters on our house. So they've moved a little bit further away. Last class they were right by my window where I'm sitting. And it was a little noisy. So hopefully you guys won't be able to hear that. The mic will filter that out. But yeah, now I adjusted the score a long time ago to only be out of 3 points instead of 5 points. So on the 3.04 quiz in the gradebook, you should see that it's out of 5 points. So if you got, now this might not have been adjusted, Mason, before you took it, and so maybe when you took it, your final score showed 80% because I hadn't fixed that yet. But I did go ahead and adjust that, so you guys should see that reflected in the gradebook. And if you got more than 3 points, then they're just treated as extra credit. But if you missed a couple, because number 4 and 5 were kind of, 5 was actually doable. 4, there was not even the correct answer choice over here. So this recording right here, Anthony and I went over this in tutor time. So I'm going to put this in the chat for you guys, and you can review it later if you want to double check and make sure you were doing this correctly. I wanted to have time to do it, but then PowerPoint wouldn't load forever, so I don't want to spend too much time in today's Class Connect since I do already have a recording on it. So check out 3.04, number 4, and the recording that I just put in the chat. And like I said, your score should already be adjusted for that. No, they shouldn't have all been wrong, Dustin. 4 was for sure wrong. 5 was very tricky. Yeah, so yes, you got it. You got it, Neil. So send me that in a K-mail, Neil, and I can fix that one. Yeah, so the link is for 3.04. Yep, and we just went over number 4 and number 5 on the quiz. Okay? I did adjust it now. I fixed it to where there is an answer, a correct answer there, but yeah, if you took it earlier and you know there's a mistake, just send me a K-mail and I can fix that in the gradebook for you, okay? Okay. Yep. Okay, perfect, Mason. Just send that to me. Just to remind I'll write a note too, but never hurts to send it to me again. All right, so let's move on to some new stuff. Okay, so the iReady test is scheduled for March 7th, which is this upcoming Monday. So you'll see in the weekly schedule that there is time for you to take that last iReady test. So yay, it's the last one. So do your best on it. It isn't for a grade in here, but we do really look at that heavily to see what you might need intervention with, that you're not getting in here, because iReady covers, a lot of other stuff that we don't cover this year in geometry. So maybe, you have some weak algebra skills that we should still kind of beef up. Then the iReady will catch that. Okay? So yep, just relax, do your best on Monday, and then that is the last one of the year. Okay? So you can relax and know that's the last one. Okay, now Atira noticed there was and you guys might have also noticed, but in 3.04, in the content, there was a factoring type question where you had an x squared in there. And it doesn't come up too often, but every once in a while, especially this semester, you'll start to see these questions popping up a little bit more. And so I wanted to just cover a couple of these questions. The one that Atiro found was when you were setting up a ratio, I think, wasn't it? Right, and it skips steps on the example because it assumes you know what you're doing from Algebra 1, which may be true, but you kind of forgot some stuff from last year sometimes. That's been a while ago. So this is where you would want to use factoring, and how you will know to use this, because that's always the key. You can factor like a madman, but if you don't know when you need to factor, then that's not going to help you, right? So you have to know, when would I ever use this? Well, the key is if you have an x squared in your problem and an x term, okay? So a term with an x squared and a term with an x, then you'd want to factor, okay? So if you only had an x squared and that was the only term that had an x in it, then you can go ahead and just get the x squared by itself and then square root. But if it's this particular example, you have an x squared and an x term, so you can't use square root in this case. Okay? Oh, okay, there we go. Just here's going to challenge. Anybody remember how to do this? If you had 5x squared minus 14x plus 8 equals 0, and I said, tell me what x is. Solve this. Anybody remember? No, x isn't 0. Atira wants to know if he's the only one that forgot. I bet you are not, for sure. I don't see the chat box lighting up. Yes, and that's okay. That's normal. And again, that's a good point for iReady. That's what iReady checks to see if you know, it'll give you oftentimes questions on factoring to see, okay, do you remember how to do that? And if you don't, then after you get done with the diagnostic test, you can actually go in and there'll already be lessons set up in iReady if you want to go in there and do that to practice on the stuff that iReady figured out. Okay, like, yes, the geometry stuff, you got a lot of that because you've been doing that this year, but algebra, it looks like you forgot some things, so let's go back and review that. So that's a really good way to use iReady, just so you are fresh on everything, because you guys have figured out so far in geometry that you still have to remember your algebra, right? All right, so it doesn't look like anybody remembers, so you're not alone, Atiro. You don't have to worry about you being the only one that forgot. So here's what you want to do. Okay, you're going to make a chart. Yeah, you don't have to. I mean, well, I'll say you in particular, Atira, don't have to. There are certainly some of you, I don't think there's too many in this class, but there are a few that, you know, if you guys test particularly low, I will ask you to go in and do it. So it's more of just a thing where it's a benefit to you. So if you'd like to, after you take your diagnostic, go in and see what it has for you to do, that would be great. Okay? All right, so what you're going to do is you're going to take, so you'll see here we have 3 terms. This is your first term, second term, and third term on this side of the equation, right? So here's your equal sign. So everything over here to the left of the equal sign is the left side of your equation, and then everything over here is your right side of the equation. All you have is 0. Now, that's another thing too. This problem's already set equal to 0. If you look at your problem and you see maybe the 8 is over here, the 5x squared and the 14x are on the left and the 8's on the right, that's always the first task, is to get the equation set equal to 0. So you always want to bring everything over to the side where the x squared term is. Okay? Then what you do is you take the coefficient of the first term and multiply it by the coefficient of the last term. Okay? So it doesn't give you your iReady results when you logged in, Amelia? I thought it would do that. Interesting. Well, if you guys are really interested, I think I mentioned that first semester, I can send it to you. I don't know who's in charge of sending those out, or if anyone did that. I don't know. I don't know if that was something that we did or not, but I can get it to you if you're really interested. Okay? All right, so you want to take the first coefficient, the coefficient of the x squared term, and multiply it by the last term. So 5 times 8. So what's 5 times 8? You guys can do that part. Yep. And we want to find factors of 40. Okay, positive 40. And the sign's important. So factors of 40, that's what we're going to find in the first column. Go ahead if you guys want to start filling those in. But in the other column, we're going to find, once we find all the factors we can think of, we want them to add to the middle coefficient, the one that's in front of the x term. So we want them to add to minus 14. And that's going to be our magic combination. Okay? Right, Atira, yes. I didn't mean that you're going to, yeah, that's totally right. I was just hoping that FOIL would jog your memory. But yes, this is reverse FOIL. And sorry, I don't mean to, I certainly could have gone into more detail, Atira. I just wanted to see if that jogged your memory first, because sometimes, you know, you'll be like, oh yeah, I remember how to do that. Yeah, so see, there you go. You're remembering some parts of this, Amelia. So FOIL is where we have like you have x plus 8 times, x plus 2 equals 0, and we use FOIL to simplify that. Okay, this is going the other way. So if you had the line below this, and you're trying to get it to look like this, where you have the parentheses in it, that's where we're headed. So we're gonna factor this. Okay, so when you do FOIL, you're unfactoring. We are going to go back to factoring. We're going to make it look like this. Okay, so I don't see lots of answers here, but for example, 1 times 40 is a real obvious factor of 40, right? 4 times 10. Okay, what else? Oh, thanks, Atira. Oh, shoot, sorry. There you go. Keep going, fill that in. Okay, 2 times 20, yes. 5 times 8, very good. Okay, which one of those add to minus 14? You're like, I don't know, none of them, right? So don't forget too here that you could have a minus 4 times a minus 10, and then it's going to add to minus 14. Minus 4 times minus 10 is still positive 40, but it adds to negative 14. So that was one trick. So it's going to be, now here's where it gets tricky. This method works really great if the coefficient right here is 1. If the coefficient here is 1, then these give you your answers right here. Okay. Now this one isn't quite as easy. We have a 5 here. And so we're going to have to do a little bit of finagling to get the answer, but you know that the overall factors are going to be like 2 times 2, 5 times 2. Those are the prime factors of the 4 and the 10. So it's going to be some combination of those prime factors. So let me write the parentheses, and I think it won't be too bad because we have a 5x squared. Okay, so here's where we're going to, now that we've figured this combination out, we're ready to fill out our parentheses. Now you guys remember from FOIL, remember FOIL means first. So if you're going to FOIL this example that I have up here, the first term in each parenthesis is x and x, and if you multiply those together you'd get x squared. So I would want to do 5x and 1x at the beginning of each of those parentheses, because if I do that FOIL and I do 5x times 1x, I'm going to get 5x squared back, which is what I have here. Yes, this has an x in the middle right here, Chiro. So you'd set it up just like this. Yep, but there's a positive 1. That's the coefficient there. So you would treat that positive 1 like your negative 14. Okay. Okay, now I'm going to fill out the next part and then I'll show you why. I'm going to put a 2 here. Or sorry, I'm going to put a 2 here and a 4 here. Okay, and I'm going to make both of them negative. And then I'll show you why this would help me out to figure that out, okay? So let's write out that FOIL. F-O-I-L. Does everybody remember what FOIL stands for? F stands for the first terms get multiplied together. Okay, so if I was going to multiply the first terms in the parentheses, it would be the 5x and the 1x. Let me grab a different color. Yep, good. It's our first, outer, inner, last. So the first terms would be the 5x and the 1x, and that would give me 5x squared if I multiplied those back together. Okay. Now this part, that looks good because that's what we wanted, or we wanted it to be the same as 5x squared. Okay, so we have the 5x and the 1x in the correct spot. So this, you normally don't write this part out, but I'm going to show you how I would double check to make sure I have all my numbers in the right place up here. Okay, so first terms multiplied together, it's looking good so far. Okay, now we're going to move on to the O, which is outer terms. So the outer terms would be the 5 and the -2. So not only the number but the sign. You want to don't forget to multiply the sign. Okay, and that would give you a -10x. I stands for inner. The inner terms are the -4 and the 1x, which would give me -4x. And L stands for the last. So the last would be the -4 and the -2, which would be +8. Okay. And then if I combine like terms, these two in the middle are like terms, I would, let me change back to a darker color. I get what I started with. So this is my double check to make sure that I did the problem correctly. So see how that matches what I started with? Okay, and the reason that this part helped me was I could see if I could see these two middle numbers here, the -10 and the -4. I knew I needed to get those numbers that I placed up here. When I did the outer and the inner terms, I knew I needed them to multiply to these numbers. So that helped me out there a little bit. Okay. Now we're not quite done yet. But this part here, this line right here, that was our answer. This stuff here was just my double check. This was my work, my check to make sure I had everything correct up here. Okay, but this would be, if you were asked to factor, this would be the answer you would give. Okay, now this isn't x, because remember when I started, I said, okay, if I gave you this problem, can you tell me what x is? So that was our goal. What you have to do from here, because it's saying this stuff times this stuff equals 0. So you have to find the x that would make that happen. Well, something times 0 is 0. So what you really want to find out is where would 5x minus 4 equal 0? And where would 1x minus 2 equal 0? So you kind of break it into too many versions from here, too many problems, many algebra problems. So this would give me 4/5, and this would give me 2. And those are two answers for x that would work. And you can, if you don't believe me, use your calculator or work it out by hand and check it out. Okay, plug 2 in up here and see if you get 0. Plug in 4/5 up here for x, and you should get 0. Okay. Okay, I was going to do this one. Well, let's see. How about we just do that one that you have, Atiro? So instead of this one, I'm going to go through this one a little faster because I don't want to spend our entire class connect on this. But this was the one that was given in the lesson. Okay. I'll do this one a different way. Let's skip the chart this time because I know some of you didn't learn it that way, so that might be, some of you might find this way easier. I know in the first spot in each parenthesis that those two numbers, when I multiply them, have to give me this 2x squared. So the only thing that multiplies to 2 is 2 times 1. I know that has to be 2x and 1x. Okay? And then the second number in each parenthesis has to multiply to this minus 55. So a lot of times you probably just guessed and checked. So for example, like 11 and 5 multiply to 55, that's one possibility. Oh, Anthony thinks that's it. Okay, good. Well, that's good. Let's check it out. So what signs would I have to have? Because negative 55 means one of these has to be positive and one of them has to be negative, right? Can you guys see which way we'd want it? Okay, so positive here and minus here. Let's check it out. Now, a quick way to check it, you don't have to work the whole thing out like we did on the last one. Just check the inner and the outer terms. Okay, if I do 11 times 1x, I get positive 11x. If I do 2x times minus 5, I get minus 10x. Is that going to add to my middle term, positive 1x? What's 11x minus 10x? So that's why I'm saying these two, your inner term and your outer term, multiply to these values. If you add those up, yep, you do get that positive 1x. So remember x, remember that there's always a 1 in front. So if there's no coefficient written, there's always that 1 sitting out there. Okay? So that means that this is looking good. This is a correct way to factor that problem. We're not done yet, though. Once you find out what it factors into, then what do you do with each of these factors? Because our goal is to find x. Well, okay, so I kind of confused you on that last one, Anthony. I did FOIL on the last one. The reason that I FOILed on the last one, though, was just to double check my work. So you could FOIL to double check it. I did my check a different way this time. I just did the middle two terms, and I said, okay, I'm going to get 11x and minus 10x, and if I add those, I get my middle term back. So I knew I factored this right. So no, yeah, and this is where that's super common. That's a very natural thing to want to do, is to FOIL this. But what you actually want to do is you want to take just each parenthesis, the part that's in parentheses, and set it equal to 0. So you want to take the 2x minus 11, set it equal to 0, and the 1x or the x minus 5 and set it equal to 0, and just solve those two little mini problems. Yes, Mwada got it. So here I'm going to add 11 and divide by 2 on each side, and then here I'm going to get 5. So my two answers for x, and most of the time when you have an x squared, that's a good hint you're going to have two separate answers. And in this case we do, just like the last problem, x can be either 11 halves or it can be 5. Either one of those would work. Okay? Well, technically that's true, except that you don't quite want to. We're not exactly saying that, Emma. So it goes back to this part of the problem. You're saying the parentheses here stand for multiplication, right? So you're saying 2x plus 11 times x minus 5 should equal 0. So what you're really doing when you break it into those two mini problems is you're saying that if I have, like, for example, let's say this first, or just remember, like, if you have 0 times 2, that's going to equal 0. Or if you have negative 100 times 0, it's going to equal 0. So what it's saying is if this part of the problem is 0, if you figure out the x value, and we figured out 11 halves, okay, if I put 11 halves into the problem right there, 2 times 11 halves gives me, 11. Oh, oops, there's a sign error. I transferred, this should be plus 11. So when I solve it, this will be minus 11 halves. Good thing we double checked our work. So if you plug in minus 11 halves right here, and you multiply that by 2, you're going to get negative 11. Negative 11 plus 11 is 0. So in other words, all this part of the parenthesis is going to end up being 0. And 0 times whatever this stuff ends up being is going to be 0 overall. So it's saying this answer would give you 0. Yeah, you can make guesses. Most of them are, pretty straightforward, so it's certainly fine to do that, Ichiro. Or you can do this chart, and remember how that kind of gave you a hint, maybe, a little bit, headed you a little faster in the right direction. Okay, so remember how I said the reason that we found factors of 40 that add to minus 14 is that quickly helps you figure out what these two middle ones are supposed to multiply to. So I need to put 2 here because I know from FOIL that when I multiply the last terms together, I need to have a minus 10. So like you might have guessed and checked and put 4 here and 2 here, but if you did the little chart, you'd say, oh, no, I know I got to put 2 here because when I multiply it by the 5, I need to get that 10. Okay? So this is normally something we would probably work on quite a bit if I was teaching this in algebra. I apologize if this is kind of still like out, kind of losing you. The good news is you're probably not going to have to do this very much, but it does come up, and I wanted you to, it's a good point. We have a little extra time. If I don't make it through everything today, there is a recording already available for 3.07 and 3.08, but let's try to dive into 3.07 with the time we have left. And if you still have questions on factoring, let me know. I can send you some more practice problems on factoring too, if that's, if you're like, ooh, I don't know, I'm really rusty on that. I'd like some more practice. I can do that. So just let me know, okay? But I hope that at least jogged your memory to where you're like, okay, yeah, I think I can get that now. All right, so 3.07 is on the side-splitting theorem. And the side-splitting theorem says a line parallel to one side of a triangle divides the other two sides proportionally. So we're looking at the big triangle here, EAB, and there's a line inside of that triangle, line CD, and it's parallel to the bottom side. And remember, those little arrows indicate parallel. Okay? What it's saying is that the other two sides are divided proportionally. So it says AC over CE. So AC, which is just that little segment, a part of the side of the triangle, over the other part of the triangle is equal to, on the other side, BD. So again, it's like matching up. The AC is the smaller part, the BD is the smaller part, and it's proportional to DE. Okay? Oh, that would be extra challenging, Atira. You won't have that. You won't have that in this class for sure. But yeah, if you did, that rarely happens. But if you did, you would just treat it the same way. You'd find factors like if your fraction was 1/4, a possible factor that would be 1/2 times 1/2. So it is doable, but it's definitely challenging. You won't have one quite that difficult. If, also don't forget, guys, you could use the quadratic equation on that. I don't know if you remember quadratic equation, but quadratic equation would work on any quadratic, like if you have an x squared term and an x term, quadratic equation would work. Okay? Yes, exactly, Atira. It's doable, but it's difficult. So I would probably jump to quadratic theorem in that case, and we'll talk about that another day if you want to talk about that one. Okay, very good. So yeah, let me change your polling. All right. So C, is that the correct answer? Do you guys agree? Okay, and that does look good. Again, AC over CE, so AC over CE. So you can see this proportion, we're just working on one side of the triangle, and then we jump over here to the other side of the triangle, and we just match up the pieces. BD would match with AC, and CE and DE match up. So you just keep everything lined up on both sides of your equal sign. Okay, so that would be how you could use the side splitting theorem to set up a proportion. Okay, so now we're actually going to set some proportions up using the side splitting theorem, and we're going to actually go ahead and solve for x this time. Anybody want to give these a try? I have a couple up here. I have a couple volunteers. All right, Anthony's one. All right, Anthony and Amelia, go for it. So Anthony can do 6 and Amelia number 10 over here. Don't worry, I don't think we have any factoring on this one. So don't forget, while I have students volunteering on the board, I do want you guys to try it yourself. See if you can beat them, okay, or at least follow along. You know, try it yourself, because if you're just staring at the screen and letting them do it, your brain isn't engaging with the problem, and you're not going to know whether you get this or not. So grab a piece of paper, grab a pencil, try it. If you get stuck, that's okay. That's part of the learning process. Then you can look up on the board and say, oh, okay, now I see what I should have done, and then continue. Okay? So try it yourself. Another thing you want to ask yourself before you start these questions, I mean, this one, obviously the direction said, use the side splitting theorem. But make sure you know what are the qualifications for when I can use the side splitting theorem. So it has to be where a segment is inside of inside of a triangle, and that segment is parallel to one of the sides. Okay. All right, very good. Looking good so far. So we'll just look at Anthony's. So he did SV over VT equals UW over WT. And I love how both Anthony and Amelia use the letters first. I really find that that helps you guys not get confused. If you try jumping to the letters and the numbers first, like the X number or the X letter, it's easier to make mistakes that way. So I do think that it's a really good idea to go ahead and use the names of each segment first. And then Anthony plugged everything in. Now he's cross multiplying. Looking good. Okay, let's check Amelia's over here. So we have AD and over DB is equal to CE over EB. And then she plugged in what AD was, what DB was, what CE was, and what EB was, and then cross multiplied. So you guys finding a common theme in this unit, right? Lots of cross multiplication. So again, anytime you have two fractions with an equal sign in between, that's what you want to do to solve it. Okay, what do you guys think? Give me a thumbs up if you agree with Amelia, number 10. Anybody get number 10 done? Still working on 6. Okay, that's fine. I know it was a little bit challenging. Oh, good. Now, yeah, number 6 was harder. Anthony had a little harder question because, and maybe I'll show that. Let me write that in up above your. So when you do 14 times x minus 4, you want to write it like this? Well, unless you're Anthony. Anthony looks like he's just fine you know, he understands how to distribute without writing it. But if you're like looking at Anthony's work and you're like, what? Where did they get 14x minus 56? I don't get it. Okay, so here's where he got that from. So you would want to write this step in if you're not Anthony and you're confused on this. But if you followed what Anthony did, that's fine. But if you do 14 times x minus 4, you need parentheses around the x minus 4. And then what you do to get the 14x minus 56 is you distribute. So 14 times x gives you the 14x, and then 14 times 4 gives you the 56, and then the minus gets brought down. Okay, so yep, this looks good. All right, all right. And then you end up with, and Anthony flip-flopped sides of his equation, which is also allowable and doable. But in case some of you aren't following, what he did was he took the 14x minus 56 and he put it over on the left side of his equation. And then the 126 he put on the right side of the equation. Okay, if you had the reversal of that, that's fine too. Oh yes, yep, so right here, yep, Tiro caught that. In order for this 56 to cancel out, you'd want to add 56. Anthony, but other than that, beautiful job. So let's see, if we do 126 plus 56, and that's going to give us 182 instead of 70. Let's see, let me erase this part down here for you, Anthony. There you go. So put plus 56 instead of minus 56 there. How's everybody feeling about these two problems? Are there anybody out there that's just completely lost? Nice, Emma. Emma's encouraging you up there. Good job. Yep, very good. So if we have plus 56, then this cancels out, and you just have 14x left on this side of the equation. Then we have 182 on the right side, and then if we divide that by 14, we get 13. So x equals 13. Wow, so those were close. One was 13 and one was 13.5. That's interesting. All right, very good, very good. Yeah, it doesn't happen all the time. Very nice. I like these little characters you guys are making. Very nice, very nice. All right. Oh, now this one we might get into factoring. I don't know. Let's see. It looks like a possibility anyway. Anybody want to give this one a try? Tiro, you want to give this one a try? Any brave souls? You want me to do it real quick? We only have 3 minutes left. Now, this one, oh, good point, because sometimes we do, huh? But nope, yeah, on this one, you're right. We don't have to substitute it in. It was just asking for x, so we're good. Okay, this one, we want to find MP. So this one, we will have to substitute x back in right here once we get it. All right, so we could do one possibility would be LO over ON equals MP over PN. Okay, now you could also do it this way. You could say ON over LO equals NP over PM. That's fine too. Okay, so either one of those setups is fine. I'll just go ahead and use this one. But just so you know, I don't want you to stress out about, oh, which segment do I start with? It doesn't matter, again, as long as you keep everything matched up, you should be okay. So we have 4.5 over x minus 3. So now I'm just substituting in everything I know. That's 2. Now I'm ready to go ahead and cross multiply. So I'm going to get x minus 3 times x plus 5 on the left, and then 4.5 times 2 would give me 9 on the right. Now, you're probably thinking, well, this is looking okay because it's already factored, right? So we could just say the answer is set this equal to 0, set this equal to 0. But you can't quite do that. It would be nice if it was that easy. But remember the very first thing I said? What do you have to have it equal to over here? Remember on those last the 2 examples we did at the beginning? What were those equal to? 0. So yes, Anthony, you're right. First we have to FOIL, then we have to unfoil. Okay, so if it's not set equal to 0, then you have to FOIL first. So we do x squared minus 3x plus 5x minus 15x, or minus 15 equals 9, and then we subtract the 9 so that we get our 0 over there. So we have x squared minus 3, or actually we can combine these. See how these terms here are like terms? So we can go ahead and put those together also. So give me a positive 2x. And then minus 15 minus 9 would be minus 24, right? And then over on the right side I have 0 now, because I had 9, I subtracted 9, I have 0. Okay, now we can unfoil, okay, or factor. So let's see if we can figure it out. We'll just put our parentheses down here. Now x squared, okay, so in the first part of each parenthesis, we just want to put numbers in here and letters in here that gives us x squared. There's really only one way to get x squared, is x times x. Okay, okay, good. And Anthony says, I think it's 6 and 4 here. And which one would be positive and which one would be negative? And how did I know that? Because what are you looking for? Where are we getting the 6 and the 4 from, first of all? In this line up here, where are you getting? How do you know it's 6 and 4? What number are you looking at? Savannah's remembering how to do this. Awesome. Yeah, you guys are right. It's positive 6 and a minus 4. Yeah, so the 6 and the 4 are coming from the 24. So you're finding factors of 24. So 6 times 4 is 24. It does need to be a negative 24. So that's how we knew one of these numbers needs to be positive and one of them need to be negative. And the outer and the inner, when you multiply those together, that needs to add up to your middle term of 2x. So if I multiply 6 times x, I get positive 6x. If I multiply x times negative 4, I get minus 4x. And that looks good because here, if I add these two together, I would get positive 2. Okay? So now to get my answer, I have 2 little mini equations. One of them is x plus 6 equals 0, and one of them is x minus 4 equals 0. So here my answer would be negative 6, and here my answer would be 4. So you have 2 possibilities. Which one is going to make sense for this type of problem? We talked about this first semester. Can distance ever be negative? Yeah, you guys got it. It has to be positive 4, right? Now don't forget, you're not quite done. I know this is the problem that's gone on forever already, but sometimes that's how geometry works. So you got to plug that in. 4 plus 5 would give you 9 for your final answer. Okay? So it's a good thing we've reviewed factoring because we're going to need it every once in a while here. So like I said, if you're having trouble with that, please let me know and we can go over some more problems. I do have to head to tutor time right now, so feel free to come there and we can also work on factoring in tutor time. Okay, but I hope that helps. If you need some more info on 3.08, I do have a recording. Do you guys all know how to get to the recordings, right? Anybody need help finding that? Okay, yeah, I hope that helped. I definitely think the factoring thing might have been confusing. I don't know if that's where you guys were getting tripped up, but hopefully if you get one of those problems now, you'll know how to do it. All right, see you at tea time, Anthony. Bye, guys.